Hi and welcome to today's session on conditional probability trees. So when we're talking about probability trees, we are talking about visually showing the probabilities using diagrams. And in this case, we are using the conditional probability, so where the probability is dependent on the probability of an event happening prior to this. So using an example of playing cards, of taking out maybe two red cards out of a pack where the cards are not replaced. So this is going to be conditional probability. So starting off with the first card to be drawn, which has given me a choice of a red or black card. So probability of each of these is a half, or 26 over 52. After this, the next card to get drawn will be a possible red or black card, depending on whether or not I took out a red card, and the exact same for the black card. Now, my probability for these are going to be changed because we are talking about conditional probability. So we are talking about all these being over 51 because there are 51 cards left in the pack. But now 25 of the 51 cards are red because we've already taken out a red card on this branch, but there are still 26 black cards within the pack. On this choice, if we took out a black card, there are still 26 red cards, but there are 25 black cards left in the pack. And if we was looking to maybe look at the probability of drawing out a red and then a red, we'll be looking along these branches. So it helps us actually calculate probabilities and show it in a more straightforward fashion. So first, another example, we've got the probability of taking a pepperoni pizza and then coming back and taking a vegetarian pizza at random. Each pizza's got 6 slices and we've got the choice between pepperoni, Hawaiian and vegetarian. So here's my first choices. I've got my pepperoni, I've got my Hawaiian and I've got my vegetarian. So the probability of taking any one of these on my first trip is a third because there are 18 slices of pizza in the whole. 6 of the slices are pepperoni, 6 are Hawaiian, and 6 are vegetarian. And after each one of these, for my second trip, each one of these have got 3 possible outcomes: pepperoni, Hawaiian, vegetarian. But the probability for these is obviously dependent on what I took beforehand. There are 18 slices here, so taking a slice, each one of these is going to be over 17. And each one is going to be left with 6 slices unless I took one of those slices in the first go. So here I took a pepperoni, so there are only 5 slices left of the pepperoni. Here I took Hawaiian, so there are only 5 left for the Hawaiian. And here I took a vegetable, so only 5 left for the vegetable. So the probability of choosing a pepperoni and then on the second visit choosing a vegetarian. So we've got 1 over 3 times 6 over 17, which gives me 2 over 17. And that's the probability of choosing a pepperoni and then choosing a vegetarian pizza. But we could have a slightly different one where we could actually choose a pepperoni and a vegetarian on either visit. So a bit more of a complex idea. But we are using the exact same notion. So we've got the probability of taking a pepperoni and then taking a vegetarian, which will give me that outcome. But we've also got the probability of taking the vegetarian and then taking a pepperoni, which would also give us the same outcome. So we are going to use a third times 6 over 17 for this outcome just here. And we're going to add that to a third times this outcome here, 6 over 17. And that gives us 4 over 17 as a probability of choosing a pepperoni and a vegetarian on either visit. If you like what you see, please subscribe. Thank you very much for watching.